Okay, so we're going to finish this problem using the half angle formula. So we figured out that 30 is is twice 15, so 15 is half of 30. So everywhere that I see an x, I'm going to put a 30. Alright, so now you need to look at your unit circle and figure out what the cosine of 30 is and what the sine of 30 is. So if you look on your unit circle, the cosine of 30 is radical 3 over 2, and the sine of 30 is 1/2. So now I'm going to get a least common denominator up top, which will become a 2. So I'm going to turn this 1 into a 2 over 2. Put them over the same denominator, dividing by 1/2. When you divide, you flip and multiply. The 2's cancel and you're finished. Now you can really see how much simpler that is than this. Okay? So it is up to you. I'm letting you pick. I'm not going to say that you have to solve a problem a certain way. Okay? If you like the half angle formula and you can make it work, go for it. If you don't like the half angle formulas, you like the other way, go for it. It's up to you. Okay, so there will be some times where you absolutely have to use the half angle formula, and a good example of that would be if you have 22.5. Okay, having some technical difficulties. Leave it to me. Okay. So, for example, if I'm doing sine of 22.5, I'm going to have to use a half angle formula because 22.5 is half of 45. Now, if you want to use a sum and addition formula, I mean, you just can't do it, okay? You're going to have to use a half angle formula. But if this was something else, like 15 or 75, then you could really pick which way you want to do it. Okay, so we're going to use our half angle formula for sine. So sine x over 2 is plus or minus 1 minus cosine pi over 2. Okay? The plus or minus depends on what quadrant it's in. And so if I say it's in quadrant 3, we know everything, the only thing in quadrant 3 that's positive is tangent. So I would put a negative out in front of it. That's all this part is. So I'm just going to plug in 45 everywhere that I see an x, and so 45, cosine of 45 is radical 2 over 2. Again, you're going to turn this 1 into a 2 over 2 to get a least common denominator. I'm going to combine that to minus radical 2 over 2 divided by 2, which is the same as multiplying by a 1/2. And so I get 2 minus radical 2 all over 4. You can leave your answer like that. You can simplify just the bottom part. And you can do a couple of other things to clean it up, but I'm totally fine with this. Okay? Let's talk about the double angle formulas. I'll just do one of those examples. These are pretty simple. It's mainly just a lot of SOHCAHTOA review. So for example, if I were to tell you that tangent is, let's say 1 over 2, okay? And we're in quadrant 3. So what I need to do is I'm going to find the double angle for sine, cosine, and tangent. I'll go ahead and write down my formulas for sine. It's 2 cosine sine. I'm not sure why I used t's. It's really weird. So I will just stay consistent with that. Let's see, 2 cosine, tx, whatever. Like, it doesn't matter what you use. I'm not too picky. 2 sine times cosine, or 2 cosine times sine, they're the same thing, because it's just multiplication. Cosine, I'm going to use cosine squared minus sine squared. This, the order does matter. You don't want to flip those around. And for tangent, I'm just going to use sine and cosine to give me that answer. Okay, so we're back to earlier in the year where here's x, this is tangent, I've got opposite over adjacent. So opposite, adjacent, I need to use Pythagorean theorem to figure out what the hypotenuse is. So 1 squared plus 2 squared equals c squared. Let's see, that is 1 plus 4, that's 5, so the square root of 5. Now, if I give you a sine or cosine problem, make sure that you're going to have a b squared. You'll be solving for that. And you always want your hypotenuse to be bigger than everything else. So I'm going to write down my ratios for sine and cosine. Now, those will both be negative because I'm in quadrant 3. And when you go back to this stuff, tangent's the only guy that gets to be positive. So I've got sine is opposite over hypotenuse. And for cosine, I've got adjacent over hypotenuse. For the sake of this stuff, you could probably leave the radical on the bottom because you're going to use those later on. If it bothers you and you want to rationalize them, that's fine. I'm just going to leave them like this because I don't think it's going to cause an issue. Because I'm thinking when I do part A, I'm going to be multiplying those two together, so that will make them cancel out there. And here I'm squaring it. So I'm going to be a rebel, and I'm going to leave them like this because I know that it's not going to hurt me here. Okay, let's do 2 times cosine, and you can put 2 over 1, times sine, multiply straight across everything in the numerator. 2 times 2 times 1 is 4, negative times a negative is positive, radical 5 times radical 5 is 5. And you're done. You don't worry about the signs once you get to this point. This quadrant 3 business only helps you here, okay? Now cosine squared minus sine squared. Square each one individually, so that gives me 2/5, not 2/5, 4/5. Rewind. 4/5 minus 1/5. Because when you square a negative, it's positive, but you're going to keep this negative because it's just part of the formula. You don't want to distribute that. You have to do PEMDAS exponents first. 4 minus 1 is 3/5. And for tangent, I'm going to take sine and divide by cosine. Flip-a-roo and multiply. You get 4/3 and you're done. Okay? So that is really everything that you need to know how to do. Most of the questions are coming from the homework sheet that we had and the study guide and the identity stuff. I mean, there's only so many questions that can come up. You start to see the same types of numbers over and over again, especially when I get into this stuff, the half English. You're going to definitely see a 22.5. I can always guarantee that you're going to see sine or cosine or tangent of 15. You're going to see a lot of the same kinds of numbers, the same kinds of problems, okay? So if you study these, you can do them, then you should be fine. All right, so good luck.